Good afternoon. Thank you all for coming. I know it's been a long day already, but I appreciate you spending time with me to validate my ability to talk in front of slides. Okay, good. You see, that was a joke. There will be a couple more. They're not going to get a whole lot better. So hopefully you can just keep up with me on that. Also, I've included my contact information at the beginning and at the end, so every time you find something I've done wrong, it's easy for you to tweet at me publicly to say I screwed up. That was a request from my team at the office. So here's what we're going to talk about today. We're going to talk a little bit about what's important to Netflix, how we're put together, and how the operations teams inside of Netflix keep this complex thing moving. So a little bit about Netflix. Netflix currently has a little over 69 million customers worldwide. We're currently available in 87 countries, and we take up a little bit of the internet. I don't have the Australia numbers, but as a sample, in the US, at peak time in the evening, 37% of the internet is all my fault. So Netflix, for those of you who haven't tried us out yet, Netflix is an entertainment company. The goal of the company is simple. We want to win moments of truth and delight our customers. What do I mean by moments of truth? That's not a common phraseology you hear very often. Well, this is a moment. This is an honest-to-God real family. Okay, some of you bought that, I'm sorry. This is a stock photo of a fake family. But a moment of truth, when you or someone like you or real families sit down and they have some time available in their day for entertainment and they choose Netflix, we win. We win that moment of truth. We win that opportunity for them to spend some time with our service. So getting people to do that is very important for us because it supports our goal of winning those moments of truth. And you'll see throughout the presentation there are lots of things we focus on that all come back to this. So the first thing we have to do is we need to have engaging and compelling content that people want to watch. It doesn't matter if I have the best architected system running on insert your favorite language here that never goes down if I don't have anything that people want to watch. So the first thing that Netflix focuses on is finding and curating and sometimes creating that content that we believe people want to engage with. And then we talk about engaging with the service. Once I have that content, I want you to be able to find it. So we'll change the way the service looks. So this is one of our standard UIs. This area here on the bottom is called Lolamo. That's your list of movies. There's your secret Netflix word of the day. I'm sure that was worth the price of admission right there. I told you they weren't getting better. So Lolamo, list of movies that we curate for every one of our 69 million customers. Each one of these lists is personalized to what we think you'll enjoy watching. Now sometimes we move that around a little bit. You'll notice it's a lot of the same information, but we have a little bit larger area here, what we call a hero billboard there with Breaking Bad. And we'll try those things. We're constantly A/B testing everything in the system. Every one of our 69 million customers is in an average of 13 A/B tests at any time. And that A/B test may change your UI or user experience a little bit. Things may move around on the screen. They may look a little bit differently. Different things may be presented to you. We're a very data-driven company, and we want to know what works based on the data. There's always lots of suppositions, and I'm sure any of you who've been in any kind of design meeting have had that argument about, well, what shade of green will cause someone to click on a button? Anybody ever had that discussion? Yeah, a few sad hands go up in the air, yeah. So we test lots of things, and we drive by the numbers. Whatever delights our customers the most wins. So we'll try a few different things. We'll start integrating video into this Lolamo experience. This is a recent one that I found to be kind of interesting. Netflix produced our first film called Beasts of No Nation, and we took over one of those lines in the Lolamo and made the entire thing a cinematic experience to give you an idea of what you could expect. So again, we like playing with things and trying different things out. We also realized we have different audiences. There was a supposition a while ago that kids engage with their media differently than adults do. They're less concerned about movie titles or television series or episodes. They're characters that they want to see, and they really don't care where they show up. So a UI completely based around just the engagement with characters was designed for kids and tested out. We found our kids loved it. This is now a large part of the service. We have groups of people that do nothing but curate and test and play with what we call the kids UI. This is not what we want. although it does occasionally happen. I've mentioned to some of our teams that work on these UIs over and over that we should replace this with this. So that way, at least when we're having a bad day, we're providing you, good, healthy life choice information. So what's the engine behind putting all of this stuff together? So our architectural pieces, we're going to talk a bit about the Netflix culture. It's important, and I put it first because honestly, without our culture operating the way it would, some of the other technology things we talk about would have no chance of success at all. We'll talk about the teams that make up Netflix, the systems, and then some of the software. So a few of the culture points that are important to Netflix. One of the first things, we value what we call the velocity of innovation. This means we want our software developers trying new features. We want our UI people building new tests to try things out. And we want them to do that as quickly as possible so that our customers enjoy these new features. Now, with that velocity, occasionally things will break. We accept that and we expect that. So we know that by pricing the velocity of innovation, we know that we are accepting some downtime. Now, to the credit of the people that work on this stuff, that downtime, frankly, is very minimal. But it is something that we expect. So we plan on handling that well. We talk a lot about freedom and responsibility. We want those people to be able to try new things, to make these new decisions, and get them out there in the world. We provide them the freedom to do that by taking a lot of things out of their way. So we don't have push windows and release schedules and some other interesting things that we'll talk about. And people take responsibility along with that freedom. We're also a very engineering-driven organization. The ideas for these new features and these functions and these UIs come from the engineers. We are not a top-down organization. There's no centralized single person somewhere going, I believe people would enjoy this kind of thing, please everyone make it for me. That's not the way things work. We're an engineering-driven organization. Our ideas and our efforts come from the bottom. So currently, Netflix is made up of about 50 engineering teams. We have around about 800 engineers and a total staff of about 2,000 or so in lovely Los Gatos, California. I say that oftentimes, and people in California have no idea where Los Gatos, California is. So for those of you familiar with the San Francisco Bay Area, you can see us down there at the bottom. For those of you not familiar with the San Francisco Bay Area, you can also see us down there at the bottom. Up in San Francisco, people like Twitter, Uber, Palo Alto, Facebook, Mountain View, Google, Netflix down there at the bottom. Told you a few things that we do have, a few things we don't have. We do not have a centralized network operations center. I do not have something that is a network operations center, cleverly disguised and named as something else, so it doesn't sound like a network operations center. We don't have anything like that at all. We don't have a singular software architect that decides what languages we're going to use, what libraries we're going to use, how we're going to design the system. Don't have one, don't have two, don't have any. We don't have a production release crucible. What I mean by that, there are organizations that exist where it's a long, arduous process to get your code or your idea from concept to code into production. It's a painful, long process that oftentimes kills many great ideas. We don't have that. If our engineers have an idea or a concept and a team puts them together, it goes out to production as soon as they're ready for it to go. We don't have a lot of pointless bureaucracy. I think some of that comes from being an engineering-driven organization. Those of us that like to optimize things can look at structures and go, we really don't need this. It's not helping us at all. Along with that, we don't have layers and layers of management. We have teams with a manager. The job of that manager is to hire new people into the team, provide them business context from the company, and to get out of their way. So along with that, we also don't have a lot of formal processes. We don't invest time and energy and effort in that. We're too busy building new things for our customers. So some of you may have seen Adrian's keynote yesterday. He also mentioned the same kind of thing. Netflix hires smart people and gets out of their way. That's why I mentioned we don't have a lot of those things. We want engineers to be doing things and providing them to our customers with as little friction as possible. The systems we have that make up Netflix. Netflix started in 1997 in a data center. And that's when the business started out only shipping DVDs. This was long before streaming. About 10 years later, we tried streaming. We thought this was a pretty interesting idea. Had some horrible content because nobody was interested in selling us anything good for this new streaming idea. And in 2008, a year after streaming got started, we had a fire in our data center. For those of you who haven't done a whole lot of data center work, data centers and fires are very incompatible. So we had to make a decision in 2008, what were we going to do? Do we go to more data centers? Do we shard ourselves out that way? And the decision was made at Netflix that we could become a company that was really, 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 really good at running data centers. We'd have the best hardware, we'd have the best people, we'd have the best design, but that wouldn't help us win those moments of truth. So in 2008, we started evacuating the data center. And by 2015, Netflix doesn't have any data centers at all. So what makes up Netflix if we don't have these data centers? Primarily, Netflix is comprised of two pieces. We have our own purpose-built CDN called Netflix OpenConnect. Every video bit that comes out of Netflix comes from our OpenConnect CDN. Everything else runs out of Amazon Web Services. Front-end information, data information, the apps that the apps that compute that My List for you, that Lolamo we talked about, all that back-end computation, all the data that goes along with it, all of that runs on Amazon. So we built a CDN. Why build a CDN? People ask us, haven't you heard of Akamai or Level 3 or Limelight? These other people have been building CDNs for a long time. They know how to do CDNs, and that's where we started. The problem we found was as these companies became more sophisticated, they wanted to be able to provide content distribution services for everybody for the everything. So that was everything from our large video files down to small JavaScript files and UI elements and all of these other code bits and pluggables and all these other kinds of things. So they end up with a very complex, really, really interesting system that also has some financial constraints. Anytime they place a box somewhere in the world, they have to decide what is the financial benefit of paying for this network space and this rack space and this hardware. A large part of the reason we chose to build a CDN is that we don't have those restrictions. We have different goals than they do for our CDN. So why build a CDN? We want to get the video bits as close as possible to our customers. So that allowed us to build our CDN in a slightly different way. Our goal for those Netflix boxes, see if I have, there we go, one slide out of order. Our goal for these boxes was to get them as close as possible. So we go to the internet service providers and we offer them a stack of hardware for free if they will put it inside of their network, because we want to get those video bits as close to our customers as possible. The other CDNs couldn't do that. They had to have their profit model fixed where they chose to put those things. I don't. I'm optimizing for something different. I'm optimizing for winning those moments of truth. And if you've had a previously bad experience where the video didn't look good or it took too long to load or was just for some reason unpleasant, I lose the opportunity to win those moments of truth. So we optimized for that. So we built our own CDN because we could put it as close to our customers as possible. The OpenConnect CDN itself, honestly, is very simple. The software, it's built on FreeBSD, and it runs two applications. It runs Nginx and Bird. Nginx for web serving, Bird for talking to BGP. That's all. All these boxes do is they want to get that video file off the disk and out the NIC as fast as possible. So we spent a lot of time optimizing for that. We have some of the FreeBSD kernel developers that have gone in there and retweaked drivers so we make sure we get information off the disk and out the NIC as fast as possible. We work closely with the engineers from Nginx to try to make that even better and better and better. As the sample hardware, we have a couple of generations out there, but there's a spinning disk version. It's a nice 4U box, has about 240 terabytes of spinning disk. And then we have another version, it's a 1U, has about 10 terabytes of SSDs. And we have a system called the popularity feed that will go through there and decide based on where those boxes are located in the world and within internet geography, what kind of content to put on what kind of disk. And they update that every day so that your experience is good with the things that you're most commonly watching, and we win more of those moments of truth. So there are thousands of these deployed worldwide. It's an open design. If you're curious about our hardware and software that drives that, you can learn a lot more at openconnect.netflix.com. So the other half of this, we have a little bit of investment in Amazon Web Services. A couple of you got that joke. Outside of things like Amazon.com and its versions around the world, Netflix consumes more of AWS than pretty much anybody else. So we have a slight footprint inside of Amazon. Currently, the way we're deployed, we have our software running in 3 of their largest regions, US West, US East, and EU West. We've also recently gone through a transition. That's what my 3 red arrows there kind of don't tell a good story for. where it used to be that we'd serve parts of the world out of the specific region that was close by, right? So for instance, we're in Australia, we'd serve you out of US West 2. But what happens if US West there has a problem? What options do I have? I suppose I have this option, because we haven't built this option yet. But that's not what we want, right? So what we regularly do is we practice serving any of our global customers out of any of the Amazon regions. So it means that we have everyone's data in 3 different regions. And in those regions, we've also replicated it in 3 availability zones. So any of you who might have been using the service about 3 weeks ago, if it would have been Wednesday morning around 10, I'm sure a lot of you are doing that instead of like work or school, so good on you. You would have actually experienced this as a customer. We would have moved your traffic from US West and split it between US East and EU West. And here's the goal of those efforts, that you don't notice. The last few times we've done this, we do this, by the way, at least once a month. We just shove traffic all over the place. Our customers haven't noticed it. And then, of course, we rebalance, we drive that traffic back, and customers don't notice. What's inside of those regions? We currently run about 70,000 Ubuntu Linux instances. We have a few leftover Windows instances for the Windows required DRM. And we're just now starting to explore containers. We've dipped our toes in the Docker waters as well as in the Amazon ECS service offering. They're really interesting and really fascinating, and we have to decide how we think we're going to try to use this cool new container thing. To give you an idea of some of the things that we use from Amazon. For Netflix, Amazon is very much not just a virtual private server service. We don't just spin up instances and do the rest ourselves. Part of our move both to the cloud and in selecting a cloud partner was that we wanted somebody else to handle the undifferentiated heavy lifting, the things that gave us no benefit for doing them ourselves. So here you can see a list of services we use to get those kinds of things done. We use things like SQS because I don't want to run my own queuing bus. I use SNS because I want to try to send my own push notifications out to millions of people. We use their RDS services for data storage and databases. We use EMR for Elastic MapReduce. We use Route 53 for DNS. We use ELBs, the Elastic Load Balancers, as our front doors. This is a large part of the value that we get in Amazon as a partner, is that it's not just EC2. So how's the software architecture put together? Well, we have hundreds of those microservices things a few other people have mentioned. We have hundreds and hundreds and hundreds of those microservices that a few other people have mentioned. It looks a bit like this. I'll give those of you taking notes a few minutes. Not really very useful. It does paint one picture, and to borrow the title of one of the keynotes, it's complicated. Here's a bit of a different look. That's a tiny bit clearer. Here's one that this is based on the service that does that Lolamo we talked about earlier that paints you out those list of movies. There's the call paths and the services that it calls to paint you out a series of box shots so you can pick what to watch. It's complicated. We also, in not having a singular software architect, don't have rules around what software or libraries you can use to produce the service your team is responsible for. So at Netflix, we do have a lot of Java. We have some other JVM languages running around. We have a decent amount of Scala. We do have some Clojure. The website itself, the service that talks to you if you're using a browser, is all Node.js. And then we have a myriad of things, lots of other APIs and microservices that are written everything from Groovy to Python to Go. There's a bit of Ruby hanging around. We sell some C and C++ because, hey, we talk on little tiny devices, some functional Haskell and Ruby, all of these kinds of things. And I don't think I have them all because we don't have requirements around what people can use. We trust those teams to pick the tool that will do the job best that they need to get done. Same thing in data storage. We have quite a large Cassandra infrastructure. We also use some Redis, and there's also some Hadoop hanging around. Again, there's probably even more that I don't know about. So what does this resulting ecosystem look like? So I have those hundreds and hundreds of microservices. I have thousands of daily production changes. Did I just send a shiver through any operations people that are responsible for production environments? A couple of sad hands going, yeah, that's terrifying. Thousands of production changes every day. We have those tens of thousands of instances. We have hundreds of thousands of customer interactions every minute. We have millions of customers. We have billions of metrics. And as of our last recording, over 10 billion hours streamed in 3 months worth of time. We also only have tens of operations people. Most of those operations people are software developers. They're not sysadmins, they're not ops people, they're not network people. How do we make all that work? We used to talk a lot about the Netflix DevOps culture. The only problem in talking about DevOps is that you have to spend your next 20 minutes explaining what you mean by DevOps. You've just gotten a preview of the next 20 minutes. Now we've compressed that down. We've moved a bit away from using that phraseology. A better descriptive term is we have a 100% ownership culture. Those software engineering teams that build those hundreds of microservices that are the Netflix service, those teams are responsible to design the service, those teams deploy the service, and those teams support the service. You'll notice at no point did I say there was a production release schedule they had to submit to, no outside code review, no crucible of the production release team that you had to work through to try to get your code into production. When they're ready to deploy it and support it, that's when it goes. That means that those software development teams have on-call schedules. Someone from each service team is on call 24 hours a day, 7 days a week. They're responsible for maintaining and curating all their own metrics and alerts so that they get insight into their systems. Any other insight tools they might need to understand how their software is behaving is also their responsibility. And when things don't go well, when it's time to repair or remediate, there's not an operations person that pulls out a run book or looks up a wiki page to try to figure out what's going on. It's that team's responsibility to repair and remediate their service. Whenever I give this little talk, a lot of people going, yeah, that sounds nice, but it also sounds really hard and fictional. So how did we end up here? We're pushed by scale. Netflix is rapidly expanding globally. We mentioned those 87 countries. I had to update that because we added a few more last month and a few more the month before. So we're driven by scale, where we can't just keep, even if we wanted to, adding people fast enough to do traditional operations and traditional software development, when we have a goal in a couple of years to be completely global. We don't have that option. So we rely on our freedom and responsibility. We trust people to make the decisions that need to be made and to do the work that needs to be done. We also try to support them as best we can with the best tools available. We're a heavy believer in automation. We automate everything we can think of, whether it's deployment tools, testing tools, the Simian Army stuff you've heard about, the tools that tear everything down. We want none of that to be manual. We want this all to be automated. We also work pretty hard and filter very hard in our interview process to find stunning colleagues. Earlier I mentioned the responsibility of a manager at Netflix was to hire new people, to inspire their team and provide them information. You notice that I didn't say they run project schedules, that they weren't coming up with new features, none of kind of the traditional people management kinds of things. Because when we hire people, we look for someone that's self-starting and can work on a team and can handle themselves. So the manager can provide them information and get out of their way. So we spend a lot of time finding the right people because I don't want to take an excellent team and slow them down by having the wrong person be added to the team. So we've discovered that if you enable smart engineers to easily own and operate the services for which they're responsible, that's what they'll do. Almost no friction at all when we moved to this model. Once we started giving our software development teams the tools they needed to do it well and do it easily, responsibility was natural and simple. Easy ownership is an important part of this, and it's what we invest a lot of time in. I mentioned earlier that on that operations team, the vast majority of the operations team are actually software developers writing the tools that allow other people to do their jobs more easily. So to make ownership easy, we try to take care of some of those things that normally people have to worry about when they're operating production service. When you have hundreds and hundreds and hundreds of microservices, service discovery can be a bit of a challenge. If I want to publish a metric or look up some geo data or get that Lolamo kind of thing for my little service that I'm writing, who do I talk to? Maybe there's some DNS records if I remember a name correctly, but maybe that's not descriptive enough. I'm sure like many of you, whenever we have a service, we give it a name, and then we give it another name. And then there's an abbreviation that people refer to it by. And after a while, we have no idea what we're talking about. That makes service discovery hard. So we have a service, again, everything's a service, that our services can talk to and say, you know, I need to push a metric. And they'll get back a little bit of data from a service called Eureka, Service Discovery, Eureka. Again, two names, just like I promised. And that will tell them what instances to talk to, what protocols to use to talk to them, how to talk to them, all the information that I need to have a good conversation. I don't have to look it up, I don't have to remember it, I don't have to hard code it. It's all part of my service discovery. Solid communication. I may surprise some of you, but networks are hard. Oh good, nobody's surprised. That made me feel better. Sometimes people are like, no, they're not. It's a cable. How hard could that be? You plug the two in, you're all done. Again, remember, we're in a cloud environment. So I'm on a network that runs through a virtual network layer. I have no idea about the configuration of it. Out through a physical network card that I've never seen. I don't know what it is. Over a cable that runs to a switch. I had no idea how it's configured. Into a switching fabric I know nothing about. Across a router that has a router table I've never seen. Across peering agreements I know nothing about. There's going to be some challenges in running that kind of environment. So we want to make network communication something that our service owners don't have to worry about. So we have some pieces of software some of you may have heard of. We have an inter-process communication piece of software called Ribbon that handles all the nuts and bolts of the talking back and forth. I can hand off my request to Ribbon. It will make the request out to the other service using that information from Eureka. It will talk across the correct protocols. It'll talk on the right ports. It'll ask the questions the right way. And then on top of that is another piece of software called Hystrix. Hystrix watches that communication and determines when it's healthy and when it's not healthy. It understands on different call paths what's an appropriate amount of latency to expect for this call. Some are 2 milliseconds, some are 200 milliseconds. I need to know what's normal for this call and enforce it. It gives me some pretty interesting things though. It's horrible colors, I'm sorry. One thing our system doesn't do well is pick nice colors. So the sickly green color represents a healthy network communication between two services talking to each other. At some point, the service being called starts to become unhealthy. And on an instance by instance basis, the calling service starts to realize that it's unhealthy. Hystrix is saying, you know, this is taking a little bit too long, or I'm getting too many errors back. One way or another, this is not a healthy conversation. That's when the blue pieces start to come in. And what happens there is the calling service now understands that the partner it's calling is unhealthy, and it gracefully degrades. It understands that it's not going to get what it needs from the other service, but it still needs to provide something. This is our something better than nothing kind of concept. Think back to that Lolamo I was telling you about earlier. Remember, that's personalized for everybody. So what if I can't reach that service? What if the data I'm getting back is an error, or it's too late, or it's just simply gone? I have a couple of options. I can show you that, you know, cannot connect to Netflix, please go outside and play screen, but I know that doesn't meet all of my goals. What if I could find not your recommendations, but recommendations for somebody like you, or somebody in your geographic area, or at least something, while this blue stuff is going on? So as long as our software behaves in that way, when that blue stuff happens, my calling service gracefully degrades away, and in the background keeps a thread going where it's checking on its friend to see if he, you know, wakes back up. And you'll see that after a couple of minutes, the blue starts to go away. That service becomes healthy again, and the conversations return to a nice, healthy color of sickly green. The nice thing about this, nobody had to wake up for this. Nobody got paged, no alerts went off. The system handled the known that the network will at times be unhealthy all on its own in an automated fashion. And just by using the tools available, the people that created these two services didn't have to learn anything about networks or calling each other or latency or any of these kinds of things. They used the tools made available to them so that they didn't have to worry about network communication in a healthy fashion. Continuous deployment, just deployment. This is a little bit of a hard problem. It's one thing to go from writing a nice application on your local machine to shipping out to the world to be used by millions of people. A lot of things have to happen in there. We've made an effort to abstract away a lot of that complexity from our software developers so that they don't have to think about it. I joke that the job of our software developers is to put their appy thing in the cloudy thing. For some reason, they don't appreciate it when I describe their jobs that way. This is one of our pieces of software that does that. This is an application called Spinnaker. Spinnaker makes it very easy for a software developer to take this code that does the business function that they've created and get it out there onto the internet to be used by millions of people. The idea behind the design is that anybody can look at this and understand what's going on without needing a lot of training. You don't have to have a lot of systems training, you don't have to have a lot of cloud training. You can see that there are lots of green dots. Green is generally good. A couple of red dots, maybe those aren't so great, and a couple of blue dots that are in some kind of phase state change. Some little descriptors, so we see that this is our API proxy, that it seems to be pretty generally healthy and that there should be around 250 of them. all that without any training. How do we get that out there? Deployment pipelines. So this represents a deployment pipeline for a piece of software. And you can see there are a few stages to it, but the idea is that the software gets bundled up, the AMIs for Amazon get baked and put together, they get deployed and tested before traffic's actually steered to them. And you can see that some of them there, some of the earlier ones there, failed a few tests down on the bottom. In a defensive fashion, we kept that from entering into our production environment. Sent a little note back to the developer, hey, you got a problem, you didn't pass some of your tests, you're still running the older version. Fixed it, then we can see that they're good deploys. Again, we want to make this easy. We tied this into our code repository, so as simple as committing to a repository kicks off your entire pipeline to get your code out to production in a safe and sane fashion. Data persistence is also difficult. If you've heard, is anybody here from Matt Rainey's talk from Uber? You remember that? Databases are hard, right? And even if you're a data person, databases are hard. So we offer data persistence and caching as a service to our customers, to our internal developers, because they need to be able to store data. They need it to be reliable, they need to be fast, and they need to be worldwide as fast as possible, and they need to know that's just going to be there. So we have Cassandra rings. We have different clients that we use to talk to our Cassandra systems and to our Redis systems. And we try to make those, again, as easy as making that service discovery call. I need to store some data. How do I do it? Here's a little snippet of information. I store my data, and the rest of it's handled as a service by the team that's an expert in those kinds of things. So we try to make data persistence easy. Metrics. This is a fun discussion. How many people have banged their head against metrics? Few people admit it. Some of you don't want to admit it. I get it. Metrics are hard. Not having metrics is bad. Slow metrics are frustrating. Having the wrong metrics is worse. And having incorrect metrics is disastrous. There's nothing like having a piece of information pointing you in one direction to say there's an enormous problem over here to find out that it's absolutely wrong. So how do we take something like metrics and insight for our software developers who aren't maybe necessarily insight people and try to make a tool that's easy for them to use so they can store and gather this information? We have an internal system called Atlas. Atlas currently stores and runs functions across and makes available in a matter of a couple of seconds for Netflix 2.5 billion metrics per minute. That's a lot of metrics. The goal of the team is not only to store that information, make that information available, but also to make it simple and easy for people to store those metrics and retrieve those metrics. Does us no good for people to put a lot of effort into putting data into a metric system and not being able to pull it back out, or build automation on top of it to make decisions to keep the system healthy. So this is a metrics discovery system. Makes it very easy to tap on a few things and see what kind of data is available. Once you find that data, we try to make it easy for them to put it together into something useful where they can see a few things together and get an idea how things are behaving. But then we also, really instead of having people stare at graphs, we want to drive automation off of this metric and data system. So this is an example of an Atlas alerting metric. You'll see there the blue line is the metric that we're looking at. The red line is a predictor. We are static threshold averse because there's a lot of things for which static thresholds don't work. So we try to use a lot of predictive methodology across all of our metrics. This sample, for instance, is using double exponential smoothing because it wasn't a large enough sample to use something like a fast Fourier transform. But then we see a predictor there moving along nicely until the signal falls off completely. And the yellowish greenish bars there show a violation of that particular metric. And on top of that, we can build automation. And we want to make that as easy and simple as possible. We want people to be able to use one metric, 10 metrics, hundreds of metrics, thousands of metrics that describe the state of their current software and make automated decisions off of it. Just like the Hystrix example earlier, we prefer that we don't have to wake anybody up to go fix the system. The system should be able to fix itself in most cases. So we go a little bit past metrics into actually turning that into more operational insight. This is a tool called Mogul. Mogul's a service-specific tool. It looks at a particular microservice and how it's behaving, talking to its friends, and where those problems are, whether they're network problems or calling problems or downstream errors. It makes it very simple for a service owner to say, here's my service, tell me what's wrong. Another issue, our service, people that make the software services want to make those easy to consume. So oftentimes they'll publish a small client that another service team can bring into their software, and then to access the remote service, just some small method call, something nice and local, and again, hides some of that complexity and allows people to rapidly develop. It can also mean that you end up with a dependency call tree that looks something like this, and you had no idea how many other things upon which you were dependent. A simple call to one other service all of a sudden turns into a call to 18 other services, and now you've created a dependency on something you knew nothing about. We want to be able to communicate that information quickly and easily to our software developers. Also, when you're having something strange happen, and you want to be able to sample something on a particular running instance or server, you want to get an idea very quickly and at high resolution what's going on. So there's another piece of software called Vector. We make it very simple for them to point out a particular instance, and Vector will start to gather lots of very high resolution metrics about how that particular instance is actually behaving. So they can make those quick little changes either in traffic or in feature flags or in data sets and see how it's, that's changing the way the system's actually behaving. So what does an operations team do in a company like Netflix, where all the software developers own and operate and run their own services? Nothing, so we look at cat pictures all day. Because nothing ever breaks, right? This sounds like the perfect system. Everything gracefully degrades, it scales on its own, it handles itself, it knows what to do when there are network problems, so nothing should ever go wrong, right? Unfortunate reality, occasionally things go wrong. Now, if you've ever watched any of the social media services, when there's a Netflix outage, some people are convinced they're going to die. So I want to let you know we've actually checked and no one has actually died. I told you they weren't getting better. So what does the operations engineering group inside of Netflix in a software development environment like this actually do? Well, we're made up of a few pieces. There's an engineering tools organization. They're responsible for things like that Spinnaker software and all of our automation on top of Amazon so that, again, my software developers don't have to think about it. Inside engineering, we talked about how metrics are hard and storing metrics are difficult. So this is a team that processes 2.5 billion metrics per minute and keeps all of that information in RAM so that we can query all of it and make decisions in seconds. Again, it's a tough problem. We have a group of smart people that handle it for us. We have a production network engineering team for a company that owns no networks. Let that sink in. So what does a bunch of network engineers do in a situation like this? Previously, what a lot of network engineers end up doing, especially in a software development environment, is it's an us versus them situation, right? They're going to come to me and they're going to tell me my network's broken and I know it isn't, so I'm ready to fight. It's nice in this situation now when someone comes up and says, I think I'm having network problems, instead of having to put on the boxing gloves, they're now working with the team to provide network expertise on how things behave in a network. I've seen a lot of really brilliant software developers completely abuse TCP/IP because it just kind of seemed to work. So now they act as internal consultants to help networking become a better service for the people that use it. Performance engineering. We're very interested in making sure that things happen as quickly, as reasonably, and as efficiently as possible. And in a high velocity environment, that means you're constantly working against and with those changes to make sure that your performance stays as is or better. We have the traffic and chaos teams. The only way Netflix is successful is if we manage to get all of these fascinating bits to the service. Chaos team, I'll give you a little bit on them in a bit. They're a lot of fun. And then we have our critical operations and response engineering team. These are the people that are the experts when things go wrong. We talked about the velocity of innovation earlier and how we thought that was important. Knowing that we're going to have some breakage in the system, we want to make sure we have people available that are experts in understanding the ecosystem that makes up Netflix so they can get the right people involved to fix it when it does break. Take a quick look at these three. So performance engineering. They're working about tuning the operating systems, the applications, and creating tooling that helps people understand the performance of their applications. And so it's not faceless, there's the Netflix performance engineering team. They also do interesting things, flame graphs. Flame graphs are fabulous. You have the option of looking at something like this to give you an idea where where time is being spent, or you can look at thousands and thousands of lines of stack traces. If you enjoy stack traces, please continue reading them line by line. If not, flame graphs are a nice way to get that same information. That's something that one of the tools that our performance team utilizes. Traffic and chaos engineering. Primarily responsible for traffic management. Those bits have to get to us. They have to get to us safely, securely. And there are times, I mentioned earlier, when we're shuffling those bits around the world to serve any of our customers in any part of the world, they're responsible for that. They also work on failure injection into the system. We want to make sure the system is stable, and the way that we make sure the system is stable is by trying to break it all the time. And they're also responsible for those testing frameworks. So for instance, the Simian Army. Anybody ever heard of these guys? Chaos Monkey, Chaos Gorilla, Latency Monkey. Simian Army is a basic idea. Chaos Monkey there in the front. His job is to randomly kill instances or servers in the production environment, 24 hours a day, 7 days a week. The reason that we have this little piece of automation sitting around, we tell our software designers that the loss of a single instance should not affect the healthy running of their service. You should not have that special instance. Instances are, they're more cattle, they're not pets, you don't get to give them names. We want to ensure that that happens. So we have a piece of automation that goes around and kills instances for us all the time to make sure that we're resilient to that kind of loss. Get all the way up to the back. We took this even further. We'd kill Amazon availability zones. We thought, now the next thing, we're going to kill availability, we're going to kill entire regions. So that's Chaos Kong in the back. He's a big, ghostly, scary guy. And at least once a month, we pretend that one of the Amazon availability zones has completely left, or it's having problems, or we can no longer utilize it, and we need to get all of our traffic pointed somewhere else. This is a visualization tool we have called Flux. Flux helps us visualize in real time traffic going to the Netflix systems. And what this is showing is that we're having some level of unhealth in US West 2. You'll see that error rate start to creep up. Once the system determines that that error level is high enough, you'll see it start to bounce the traffic from the upper left in US West to the upper right in US East. You'll see that redirection starting to happen. We have a proxy at the front door right behind those load balancers called Zool. Zool's our layer 7 Netflix protocol intelligent proxy. And all of those Zool instances are now bouncing traffic over to US East. So all those functions behind Zool in US West 2 are now going silent. We're waiting for DNS records to update, and you'll see that traffic will drain away completely. And now US West 2 will come effectively dark. Whether it fixes itself, some remediated automation goes on, or this is just one of our exercises. We do this on purpose regularly. It gets some time to become healthy. Once it's determined to be healthy, you'll see the reverse happen. You'll see those proxy instances in US East start to bounce some traffic back to US West. DNS will update, and will return back to a stabilized system. Now, out of those 800 engineers, how many do you think are involved to make this happen? Any guesses? 0 at best, 1 in worst case scenarios. So now we're back to a healthy state. So it doesn't matter what problem was going on in US West 2. We could have lost database systems, we could have lost caching layers, Amazon could have had a problem, there could have been peering instance issues, there could have been a bad software push, there could have been anything. And I can just evacuate my customers away from it in that amount of time. I don't impact my customers, we continue to win those moments of truth. So chaos engineering in general is the discipline of experimenting on distributed systems in order to build confidence in the system's capability to withstand turbulent conditions in production. Matt Rainey also used this quote earlier. The entire idea behind chaos engineering is we know things will break. You get certain promises from a cloud provider or from, hopefully from your data center people as well if you have data center people. Things are going to break, switches are going to go sideways, disks are going to break. Somewhere the power is going to go out. There's no reason that we should not continually test and build our systems around understanding how to behave when those things happen. Those should not be surprise failures when they happen. So finally, that core team, the critical operations and response engineering team, we handle all the crisis management. Anything that happens, we take charge of it, we run it through to the end, and we make sure that it's stabilized again so we can continue to run those or win those moments of truth. We conduct our blameless incident review processes. We get together with the people involved and we say what happened and how do we make sure this doesn't happen again. Reliability best practices. We're coaches for those kinds of things. We're responsible for the availability reporting, those magic numbers that tell people how they're doing. We're also primarily responsible for a lot of our partner engagement with companies like Amazon. Goals of that team are simple. Protect the customer experience. Ensure that any failures that do happen are unique. So it's part of the job of the people on that team when we discover a fault in the system is to make sure that we run that out all the way to the end and find the real root cause or causes of what happened. because I want every time the system fails to be a unique and interesting experience. I don't want it to be the same thing happening again. We're also the push for constant improvement. It's great to make leaps and bounds occasionally, but the best thing we can do is help people get incrementally and incrementally and incrementally just a little bit better. The team is made up of service reliability engineers. Their job is to understand the Netflix ecosystem, not only how our software pieces and teams fit together, but how it sits on top of Amazon and how that operates, so that whether they're providing information on how to make a more reliable system or participating in crisis remediation, they're the experts that know how things fit together and the right people to go engage. We've also recently added project and program managers to the team. An important part of following up after an incident involves a lot of people management, a lot of research, a lot of meetings, a lot of occasionally dotting I's and crossing T's, and we found out that for some reason service reliability engineers don't enjoy that kind of work. So we brought in people that do enjoy that kind of thing, and they have those proclivities. So we have project managers on the team. Then finally, we have crisis leaders. The job of the crisis leaders is to understand, especially in those particularly nasty situations, the impact to the business and the impact to the technology of different decisions, and to make that decision on where we're going to go. The vast majority of the time, Netflix is a context, not control environment. I mentioned earlier the job of managers is to provide people information and get out of their way. During a crisis is one of the few times that we choose to suspend that part of our culture, put someone in charge, and get this thing fixed for our customers. Overall, our job is to find and fix problems and to make things better. We do occasionally get to do things outside of our purview. These are the logos of a couple of my little projects. Is that Netflix things aren't real until they have a sticker and a t-shirt. So outside of my realm, generally speaking, I saw an opportunity to fix some problems we saw going on to networks from television providers, for which this was the first time they'd ever connected their private network to the internet. So I was able to develop a hardware and software system that allowed them to test before we deployed in a new area and do those kinds of things. This is something that we do with our engineers regularly. We encourage them to go find problems that aren't necessarily within the charter of their team or the bailiwick of their floor of the building. If we find problems, it's our job to go fix them. So these are a few that I got to do. A lot of the software that I mentioned today, everything from Atlas to Hystrix to Eureka to Etta to Vector, to I think pretty much all the tools that I mentioned today are open source by Netflix. We think there's no reason that once we've gone through the pain of figuring out how to do something, we shouldn't share that with people. You can find all of our software at netflix.github.io. There's about 60 or 70 packages up there now, everything from small automation to enormous metric systems. I mentioned some things about our culture. There's what we call our culture deck. It's the presentation of what it's really like to work at Netflix. You can find that on our jobs site at jobs.netflix.com. We're always looking for those new, brilliant, stunning colleagues. Also, there's a lot of fun information that comes out on our tech blog about the things we've done and the bits that we figured out. You can find that at techblog.netflix.com. I'm Dave Hahn. I'm a senior engineer with the core team at Netflix. This is how you can find me on the internets.